now. Okay, so our goals for this lesson, we're going to be using function notation. That is a new vocab word. We talked about functions in our lesson 1. So this is going to be kind of what we're focusing in on in this lesson, function notation. And we're going to use that to express functions that have specific inputs. And if we remember, inputs are X values and specific outputs, which are our Y values. All right, we're going to understand that function notation, what it is, and why we use it. And when we're given a statement written in function notation, we can explain what it means in terms of the situation. Now, at the end of this lesson, we will be doing a cool down on Edgelastic where you will be required to answer questions about what we're doing. So don't just passively listen to what we're doing. Really think about what you're learning, okay? Because this is really important and this is a huge concept that carries over into Algebra 2 and 3, which you definitely have to take Algebra 2. All right, so function notation 2.1. Here are the graphs of some situations you saw before. Each graph represents the distance of a dog from a post as a function of, remember that phrase, as a function of. We know that when it's written like that, that variable that comes before is our what value?
Y.
The Y value, or the output, or the dependent variable. And we know that the one that comes after is our X. Okay. Distance is measured in seconds. So if you remember last week, I know it's been an activity, dog was tied to post. Well, these are the gradation. So you can see 1 is the one the around, just the owner was, dog just walked around for that first minute and then he laid down there. Post was getting shorter and shorter until eventually he was just kind of reading the graphs and answering these questions. All right, after you finish answering those questions, you have on the next page, you have 2 more questions about the graphs as well. Okay, so I'm going to give you a few minutes to answer those questions on your own. And then whenever you get to number 2 and 3, you can choose whichever one you want to do, but send me your answer in the chat. Okay, that way I know when to kind of start going over the question. All right, ready?
Our answers for like all of them or just 2 and 3?
Just 2 or 3. You can just send in your answer for 2 or 3. Whoops. Just make sure you tell me which one you're typing for. All right, your time has started. Ready? It says use the given graphs to answer these questions about each of the 3 days. So it says, how far away was the dog from the post 60 seconds after the owner left on day 1? How far away was he on day 1 at 60 seconds?
4 feet.
4 feet. What about on day 2?
4 feet.
4 feet.
4 feet. What about on day 3?
4 feet.
4 feet. Good. All right, B, it says, how far away was the dog from the post when the owner left? Okay, so that's right there at 0. So how far away was he on day 1?
1.5 feet.
About 1.5 feet. What about on day 2?
1.5.
1.5. What about on day 3?
1.5.
Good. So far, so good. C, the owner returned 160 seconds after he left. How far away was the dog from the post at that time? Okay, so on day 1, At 160 seconds, how far away was the dog?
About 3.75 feet.
Okay, so day one, what was it, 160? It's about right there. Yeah, about 3.75. I agree with that. If you have something around there, then you're good. All right, day two at 160 seconds.
4 feet.
He was at 4 feet. All right, and then day three, 160 seconds. He was about right there, which is where?
1 foot.
Do what?
1 foot.
Wasn't exactly 1 foot. It was a little below it. 1
About
foot would be
where?
that line. It's about right there. So what do y'all think?
Half a foot.
Okay. Got half a foot. Good. Hopefully y'all are all getting that so far. All right, D, it says how many seconds. So all the other ones have given us the seconds and we had to tell the feet. Now we're given this, now we're wanting to know how many seconds passed before the dog reached the furthest point it could reach from its post. Okay, so let's look at day one. So the furthest point from its post is about right there. Whoops. It's about right there. Okay, so we want to know how much time has passed. So that's somewhere right about there. So about how much time has passed at that point. What do y'all think?
50 seconds.
About 50 seconds. Good. So on day one, it had been about 50 seconds when he was at that farthest point. Now let's look at day two. Okay, that furthest point from the post is going to be that peak again, about right there. Okay, so how far or how much time had passed?
Around 30 to 35.
About 30 to 35 seconds, somewhere in there. So I'll just put that range. So if you had anything that fell in between, fell in between that range, then you should be good. All right, day three, that peak point, if you look real carefully in your book, it actually kind of like plateaus up there, like it gets that peak, but it stays like that all the way to there, okay? So how far away or how much time had passed when he was at that furthest point?
Like 5 seconds.
5 seconds all the way till what?
20.
Till about 20 seconds, right? Okay, because it kind of plateaued up there. But if you just want to get that first initial time, it was about 5 seconds, but you could have had anywhere to like 20 seconds. All right, which brings us to question 2. And I really liked how some of y'all sent questions in for this one just to clarify it, because that's important of why they asked these specific questions. So number 2, it says, consider the statement, the dog was 2 feet away from the post after 80 seconds. Do you agree with this statement? Okay, so what is it about this question that makes you want to ask a question back?
They like didn't specify a graph. So
They didn't specify a graph, or they didn't tell you which day they're talking about. So if we look up here, what was the time? 2 feet after 80 seconds. Okay, so right here, or let me use pink. Okay, so we've got 80 seconds. Is the dog 2 feet away right there? Nope. Right here, is he 2 feet away?
No.
Nope. On day 3, is he 2 feet away?
Yes.
Yes, he is. So do you agree with this statement? Well, what does it depend on? What did we just say?
depends on like what day they want.
It depends on what day they're talking about. If you wrote like yes or no, depending on each day. Don't erase any of that stuff, okay? Because you're not wrong. Like if you wrote day 1, no, day 2, no, day 3, yes, that's fine. But just sum it up by saying it depends on the day. Okay, they weren't specific, they didn't specify. All right, on number 3, it says, what was the distance of the dog from the post 100 seconds after the owner left? What is our same problem with this one?
The day.
They didn't tell us what day. Okay, so every single day we're going to get a different answer. So once again, it depends on the day. All right, so what this activity is wanting you to see is that when we're looking at a lot of data or a lot of information, and they're asking us questions that we're supposed to draw from each graph, there has to be a way to name these graphs and to talk about them without having to use all of these long descriptions like up here. Okay, there has to be a way to explain which graph we're talking about without having to go into these long explanations and describing each graph. Okay, so we're going to talk about what that's called when we're naming these different graphs. Okay, that brings us in to this next activity right here, 2.2. A handy notation. Okay, so when we're talking about renaming these graphs without the wordy descriptions, when we're naming these graphs, we're calling it function notation. Write that down. I know I wrote mine really big over here, but you know, just fit it on your paper. Function notation. That just means to name a function precisely. Okay, it's you don't have to have all those wordy descriptions of it. Okay, it's like a shorthand. All right, so we have this situation here. It says, let's name the functions that relate the dog's distance from the post and the time since its owner left. We're going to let function F be day 1. We're going to let function G be day 2. And we're going to let function H be day 3. All right, and then it says the input, remember the input is your X, of each function is the time in seconds. Okay, so once again, time is our input. Just like we talked about in lesson 1. Okay, so the main thing you need to understand about function notation is you're going to be naming your functions. Okay, so that's what we just did here. Day 1 is F, day 2 is G, and day 3 is H. Okay, so if we were looking at this right here, I'm going to kind of simplify. I'm going to write that above it. Day 1, F, day 2, G, and day 3, H. Okay, so when we're talking about representing this function, and we're talking about the distance from the post 60 seconds after the owner left, remember this is our time, that's our input. So when you're writing a function, you put its name first. So f, this is day 1. And it wants to know it's 60 seconds after the owner left. So if we're doing our input, the input goes in this little parentheses right here. So it would just be F60. Okay, so we're not answering this question right here. All we're doing right here is we're writing it in function notation. Okay, use function notation to complete the table. We're not answering the questions, we're just writing them in function notation. So let's keep going. All right, so for day 2, if we wanted to write the distance from the post 60 seconds after the owner left, how would we write that?
G and then the parentheses 60.
Yep. Okay, anytime you're writing a function and you have these parentheses right here, the input always goes on the inside of those parentheses. Okay, you have the name of your function here. Okay, so if I see an F, that tells me I'm looking at day 1, and then the inside the parentheses is always going to tell me my X value. And in this case, our X value is the time. All right, erase this so we can write it. All right, now if we're talking about day 3, what's the name of day 3?
H.
H. Okay, then we have to do our parentheses, and inside of our parentheses goes our input, which is what?
60.
60. Okay. Now, let's look at this next one. It wants to know the distance from the post when the owner left. Okay, so once again, we're still trying to find distance, but they didn't tell us how much time had passed. We have to kind of do a little bit of thinking. So right when the owner left, how much time had passed?
0 seconds.
0 seconds. Okay, so if we were talking about day 1 and we have our input, because that's our time, what would our function notation look like?
Would it be F and then 0 in parentheses?
Yep. All right, what about day 2?
G and 0 in parentheses.
G is 0. All right, what about day 3?
H and 0.
H of 0. All right, now I want y'all to notice that these questions right here that you're writing in function notation are the same ones that we were doing right up here, A and B. Okay, so instead of having to write it in that big wordy explanation, we've just simplified it to this easy little notation. All right, and the more you look at these, the easier those are going to be able to read, the more we practice them. So don't stress yet, because I know some of y'all are probably stressing. Don't stress. All right, now let's look at this last one. It says the distance from the post, 150 seconds, so that's time, that's my input, after the owner left. Okay, so what is the name of day 1?
F.
F. All right, and we know that inside my parentheses goes my input. What is my input for this question?
150.
150. Okay, now what about day 2?
G and 150.
G and 150, and then finally for day 3,
H and 150.
H and 150. Good. Okay, so that is just us practicing kind of the basic understanding of writing a function notation. Now that we have this written, we could easily answer those questions. Okay, so, but we'll get there in just a second. Now it wants us to describe what each one of these notations is going to tell us. Okay, It wants us to describe it in context. All right, so let's break these function notations down. So first things first, I look at the name of my function. All right, I get F. What does that tell me?
Day
It's
one.
day one.
All right, that's day one. Okay, I know that. I know that every single time, always and forever, that when I look at this number that's inside the parentheses, it will always tell me my what?
Input.
The input. Okay, what is my input talking about in this problem?
Time.
Time. Now that could, the variable that you're talking about in each notation could always be different, but it will always be your input. In this case, my input is time. Okay, so on day one, whoops, I forgot to write that. How many seconds are we looking at?
15.
15 seconds. So on day one at 15 seconds, it's going to tell me the what?
The distance.
The distance from the post. So on day one at 15 seconds, oh my gosh, can't write anything. Okay, good. So not so confusing. You can see where everything is represented. There's day one, the F. 15 represents the input. All right. And so the only thing we haven't talked about is if we set that equal to something, it's going to tell us our distance. Now let's look at the next one. I'll leave it up there so y'all can get that written down. Okay, what day are we looking at?
Day 2.
Okay. How many seconds after the owner left?
48.
48, okay. So this is gonna tell me the distance, the dog. Oh my gosh, why can't I spell dog today? The dog is from the post on day 2 after 48 seconds. All right, let's see if y'all can figure this last one out. They're trying to trick you by not giving you things or not giving you numbers, but nothing changes. So what does this tell me?
The distance the dog is from the post at T seconds.
On what day?
3.
Day 3, because that day 3 is named H. Okay. All right, good. I'm going to pause the recording again. Okay, it says now we have this equation in function notation right here. It says G of 120 equals 4 can be interpreted to mean on day 2, 120 seconds after the dog owner left, the dog was 4 feet from the post. Okay, so how do they take this and get that whole explanation? Well, let's break it down. First things first, we look at the name of it. Okay, yes, I know it is only a letter, but that is considered the name of the function. So it's named as G. We know that G represents what?
Day 2.
We know it represents day 2. All right, we know that always and forever, anytime we look at function notation, this number in the parentheses will always tell me my what?
Input
The input. And in this case, our input is
120 seconds.
120 seconds. It's our time in this situation. Okay, and so then all of that will be set equal to our output, which in this case is our distance. Okay, so that's where they got this 4 feet from the post. Okay, whatever all of that is set equal to will always be your output. Okay, so I want y'all to see if y'all can do these on your own. So in the chat, before you write it in your book, I want y'all to send me what this means. Okay, I want you to send me what that first one means. Break it down just like we did. And send me what this function notation means in this situation. So it says H of 40 is how you read it. H of 40 equals 4.6. So H tells me that on day 3, that's day 3. Okay, the number inside of my parentheses is my time. So on day 3, after 40 seconds, all right, and then this last one is going to be my output or my distance. Okay, so on day 3, after 40 seconds, the dog was 4.6 feet from the post. Okay, so make sure you have that written down for part A. So we've got the what function we're talking about, we've got the input, and we've got the output. Okay, number 2 or part B. Uh-oh, we've only got one number this time. They added more letters, but we're not going to let that confuse us. Okay, so F tells me what? What day am I talking about?
1.
I'm talking about day 1. Okay, so on day 1. Okay. Then we have our input. Did they tell us how many seconds have passed?
No.
Okay, so you just write what they give you. They didn't give us a number, so we write the variable. On day 1, T seconds after the owner left, what do we know?
It was 5. The dog was 5 feet away from the post.
The dog was 5 feet from the post. Good. And now that we know that function right there, we can easily figure out what T is, right? We know if we have the graph at least. You can go back and look on day 1 at 5 feet and we can figure out what our time is at that point. We can know to look on this graph and figure it out. Uh-oh, the last one is all letters. But we're not going to let that confuse us. Okay, what day am I talking about?
Day 2.
Okay, so on day 2. How many seconds after the owner left?
T.
T, once again, they didn't tell us. Okay, how far away is the dog from the post?
D. Feet.
Good. Okay, so we've got what graph we're talking about. We've got our input and we've got our output. So we are good. Okay, so something I want you to have written down somewhere in your book. When we're talking about, let me find, maybe, oops. Maybe up here at the top of this page. All right, when we're talking about function notation, it's going to look something like this. This is your basic, anytime in general, when we're talking about functions, this is like the little symbol for it, f of x, that's how you read it. Okay, so let's just break down what each one of these parts mean. So right here, we know that that letter stands for what?
Name.
The name of the function. Okay, and we know that always and forever, this value that's inside of our parentheses stands for what?
Input.
The input. Okay, so the F by itself is the name, the X by itself is the input, but when we take all of that and we set it equal to something else, that tells us the what?
The output.
The output of the function. All right, and remember you read this like f of x. F of x is how you would read it, or g of x, or h of x. All right. Moving on to this last part, birthdays. All right, so we've got 2.3 birthdays. Rule B takes a person's name as its input. So that's going to be our X. And it gives their birthday as the output. All right, so you can see that here. So just for the record, this first table, its name, like we just talked about, is B. That's the name of the function. All right, next one, this is rule P. It takes the date as its input, and it gives the person with that birthday as the output. So the name of this table is P. That's how we will distinguish between the two of them. This first one is B. This second one is P. All right, so they've given you an example for table B already. So for my input, that was the person's name. So they gave you Abraham Lincoln, and the output was February 12th. Okay, so let's continue filling this in. So the way you're gonna have to do that is some of you I need y'all to send me your birthdays in the chat. Okay, so I'll go ahead and do mine first while you are sending in some birthdays, and then just be copying these down in your book. So I'll do mine first. Miss Frisbee, March 31st. All right, let's see here. Oh gosh, they're going so fast. Okay. Go in order. Connor, December 30th. All right, and then Kristen, January 2nd. All right, I'll give y'all a second to get those copied down. Okay, now while some of y'all may already have that done, I'm gonna go over here. Now remember, this one we're given a date, and it's the person who has the birthday on that day as the output. Okay, so I'll just continue with the ones y'all sent me. Okay, so this next one is June 2nd. Okay, that's Colton. All right, then we have February 16th. That's Natalie.
Y'all have Abraham Lincoln. I want George Washington.
And then we have the last one is going to be August 2nd. And that's Destiny. It looks like I put an E in there, but I just got too fancy with my Y. I promise I know how to spell your name. All right, get all those written down and then send me that you're done so I know when to move on in the chat. Okay, so number 1 says complete each table with 3 more examples of input output pairs. Okay, we did that. Input, output, pairs, got it. If you use your name as the input to B, so we're looking at this table up here, that's table B. How many outputs are possible? Okay, so for me, for example, I use my name as the input. How many possible outputs could there be if I'm using my birthday as the output? How many possible dates could I have put here if I'm talking about my birthday? Okay, think of Connor. All right, we're using Connor's name as the input. How many different dates could we have put if my output has to be his birthday? Don't overthink it. How many dates could we have put here if it has to be his birthday?
1.
Just one. For me, if the input has to be my name and the output has to be my birthday, there's only one option I could have done for my output. Okay? And it has, because I only have one birthday, right? So there's only one possible output, and then it says to explain, because we only have one birthday. Okay, now looking at P, the second table. If you use your birthday as the input, how many outputs are possible? Okay, so right here we did Colton's birthday on June 2nd. Is Colton the only person who could have ended up on this output?
No.
No. Who else could we have put there, Colton?
Miss Fulmer.
Fulmer, because Miss Fulmer also has a birthday on June 2nd. So, how many outputs are possible? Is there more than one?
Yes.
Yeah, we could put multiple. And then it says to explain. So why can there be multiple outputs? What did we just say?
Multiple people have the same birthday.
All right, so give y'all a second to write that down. All right, number 4, or wait, on number 2, it said how many outputs are possible. So for number 2, there was one possible output. And for the P, there were multiple possible outputs. So then that leads us to this question. Only one of the two relationships is a function. The other is not. Which one is a function? Which one of those two would be considered a function? That you have to remember the definition of one. Would B or P be the one that is a function? B. Now it says to explain how we know. How do we know it is a function? What's the definition of a function?
Only one out.
Each input only has one output. All right, and then it says for the relationship that is a function, okay, so we already decided that was B. Write 2 input-output pairs from the table using function notation. Okay, so that means you have to write it like we just talked about up here, like this. You have to name it. It already gives you a name. You have to tell me what the input is we're talking about and then set it equal to an output. Would y'all like for me to do one with you first? Or do you think you got it?
Will you do one with us first?
Yes. Okay, so first things first. We have to name the function. What is the name of the one that we already said is a function?
B.
B. Okay, done. All right, then we have the parentheses. What do we know goes inside the parentheses?
Input.
The input. Okay, so when we are looking at our function, because we're not using this one anymore, because it's not a function, we're looking at this one. What are our inputs talking about? What are our inputs? What are our inputs?
Dates, person's name.
Person's name. These are all of our inputs. Okay, so inside of these parentheses right here, we're going to write the person's name. So you can write Miss Frisbee. Okay, that's my input. All right, so that means my output has to be what? What are we talking about in this? What are our outputs talking about?
The dates.
The birthdays. Okay, so for Miss Frisbee, the output would be March 31st. And that is how you would write it in function notation, okay? Now, y'all can just do one more because they only asked you to write 2, but send it to me in the chat. And then you won't have to write it in the book because we already have one written in the book. If you want to use one that's not in the table, do your own birthday. I did my birthday, you do your own birthday. Send them in the chat. All right. Now we have our lesson summary. It says here are some graphs of 2 functions, each representing the cost of riding in a taxi from 2 companies. So the 2 companies we're dealing with are Friendly Rides and Great Cabs. For each taxi, the cost of a ride is a function of the distance. So there's that little phrase, is a function of. So that tells me that the cost of the ride is my what?
Output.
The output. And that tells me that the distance traveled is my
Input.
input. All right, the input is distance and the output is cost in dollars. Okay, so they've gone ahead and graphed it here for you. You can see that distance is on the X, cost is on the Y, which makes sense because this saying is saying the cost of the ride is dependent on how far you travel, which we know is true. Okay, so they graphed this point here, both after traveling 2 miles, and you can see one of them is 425 and one of them is 570. So we can convey the same information much more efficiently by naming each function and using function notation to specify the input and the output. All right, so they do that right here. They're going to name the function for Friendly Rides F, which makes sense. Friendly Rides F. Great Cabs is going to be G. So it says to refer to the cost of riding each taxi for 2 miles, we can write. Okay, so what it's saying here is when we're talking about the cost, we know that's our output. But they tell us our input. They tell us how many miles we traveled. Okay, so for each one, this one's for Friendly Rides after 2 miles, and this is Great Cabs after 2 miles. If we were to set those equal to anything, it would be set equal to the cost. It says to say that a 2-mile trip with Friendly Rides will cost $570. We can write this function notation. F tells me it's Friendly Rides, 2 tells me the distance, 570 tells me the cost. To say that a 2-mile trip with Great Cabs will cost $425, we can write that function notation. In general, function notation has this form. just like what we talked about earlier. We have the name of the function, we have the input, and the whole thing set equal would be the output. It is read f of x and can be interpreted to mean f of x is the output of a function f when x is the input. Function notation is a concise way to refer to a function and describe its input and output, which can be very helpful. Throughout this unit, we will use function notation to talk about functions.